Next problem. Refer to figure 3.59. A flexible rectangular area is subjected to a uniformly distributed load of Q is equal to 225 kilonewton per meter squared. Determine the increase in vertical stress at a depth of Z is equal to 3 meters under point B. So if you remember, this is the same problem that we had solved previously, except that we are determining the effect of this load at this corner. In this specific example, we see that the point of consideration is not at any of the corners of the rectangle, but it is somewhere below the rectangular load. So in a problem like this, what we are to do is to divide the rectangle in such a way that point B will become the corner. Thus, dividing the rectangle, that now becomes, and we now have 4 rectangle. 1, 2, 3, and 4. The idea now is we will be analyzing individually rectangles 1, rectangles 2, rectangles 3, and rectangle 4. Because if we are to analyze them individually, we notice that point B becomes the corner of rectangle 1. Point B is also the corner of rectangle 2. Point B is also the corner of rectangle 3. And point B is also the corner of rectangle 4. Thus, we will be analyzing them individually, and therefore, the vertical stress increase at point B is simply the summation of the vertical stress increase due to rectangle 1, rectangle 2, due to rectangle 3, and due to rectangle 4. Let us first consider the first rectangle, rectangular area 1, and in this figure, that is the rectangle that is shaded with color purple. From this figure, we see that the total length of the rectangle is 6 meters, and this part is also given as 2.4 meters. Therefore, 6 meters minus 2.4 meters, our length for the rectangle 1 is 3.6 meters. Also, since this is given to be 1.2 meter, the width is simply 3 meters minus 1.2, so B is now 1.8 meter. We can now solve for the value of M and N. M is equal to B divided by Z. The value of B is 1.8 meters and the depth is 3 meters, so M is 0.6. For the value of N, that is L divided by Z. L is 3.6 meters, Z is 3 meters, N is 1.2. From the table 3.9, you have to see to it that you are using the right table. This is the variation of i's of 3 with m's of n. The value of our m is 0.6 and the value of our n is 1.2. Therefore, this now becomes the value of our i's of 3. Now, if the values of m and n is not found in the table, you can do an interpolation, but it is best that you use method 1, which is using the equation that was given to solve for the value of i's of 3. So from the table, the value of i's 3 for rectangle 1 is 0.1431. Next, let us analyze the second rectangle, which is shaded blue. So L is 2.4 meters and B is 1.8 meters. Solving for M and N, M is equal to B divided by Z. The B is 1.8. The depth is 3 meters. 1.8 divided by 3 is 0.6. N is L divided by Z. L is 2.4 divided by 3 meters, that is 0.8. We now refer to the table for the value of i's of 3. M is 0.6, N is 0.8, therefore value of i's of 3 is 0.1247. We now proceed to the third rectangle, which is shaded yellow. L is equal to 3.6, B is equal to 1.2 meters. Same procedure, we solve for the value of M and N. M is equal to 1.2 divided by 3 meters is 0.4. N is equal to 3.6 divided by 3, this is 1.2. And from the table, the value of i's of 3 in third rectangle is 0.1063. Considering the last rectangle, which is the fourth rectangle, L is equal to 2.4 meters and B is equal to 1.2. So M is equal to 1.2 divided by 3, this is 0.4. And for the value of N, that is 2.4 divided by 3, this is 0.8. Again, from the table, the value of ice of 3 for rectangle 4 is 0.0931. So since we are able to get all the values of ice of 3 for the 4 rectangles, we can now determine the stress increase at point B, and that is simply the Q multiplied by the summation of ice of 3 of rectangle 1, rectangle 2, rectangle 3, and rectangle 4. Substituting 225 kilopascal multiplied by the quantity 0.1431 plus 0.1247 plus 0.1063 plus 0.0931, vertical stress increase at point B is 105.12 kilopascal. This is now our answer.